Section 1.4, Complex Numbers. The unit I. The imaginary unit I is defined as I equals the square root of -1, where I squared equals -1. So whenever we have a negative inside the radical, we have the imaginary I. The set of all numbers in the form a plus bi with the real numbers a and b, I is the imaginary part and the a is the real part. It's called the complex numbers. Once again, the real part is a, and the b is the imaginary part of the complex number a plus bi. So to multiply, all we're going to do is distribute, and remember that I squared equals -1. So here we have -8i times 2i is -16i squared. Then we have -8i minus 7i is plus 56i. And we know that I squared is -1, so it's -16 times -1 plus 56i. And to clean it up, my final answer here is positive 16 plus 56i. Notice this is written in a plus bi format. Example 2, we're distributing. -4 times 3, we're multiplying, is -12. -4 times I is -4i. -8i times 3 is -24i. And -8i times positive I is -8i squared. So combining here, we have -12 minus 4i minus 24i is -28i. Then we have minus 8i squared is -1. Cleaning this up further, we have -12 minus 28i plus 8. Notice we can combine like terms here, so we have -4 minus 28i. And that's our final answer. To divide complex numbers, basically we're going to multiply by its conjugate. Okay, so a complex conjugate of a number of a plus bi is a minus I. So notice all we're doing is changing the sign in the middle, and then we multiply it, the two complex conjugate, to give us a squared plus b squared. So here our goal is by multiplying the numerator and the denominator of the division by the complex conjugate, you will obtain a real number in the denominator. So our goal is, when we get done, we should just have a plain old number in the denominator. So here we have 3 divided by 4 plus I. The conjugate of 4 plus I is 4 minus I. So all I've done is change the sign in the middle to the opposite. And if you do that to the denominator, you must also do the same thing on the numerator. And I'm going to put parentheses around this so I can FOIL or distribute. So we have 3 times 4 is 12, and 3 times -I is -3I, so that's our numerator. Our denominator we have is 4 times 4, which is 16. 4 times -I is -4I. I times 4 is positive 4I. And I times -I is -I squared. So our numerator is still 12 minus 3I. But cleaning up the denominator, notice that -4I plus 4I cancels out, leaving me with 16 minus, and we know I squared is -1. So we have 12 minus 3I, and 16 plus 1 is 17. And to write this in a plus bi format is basically 12 over 17 minus 3 over 17i. I've just split the fraction. Example 4, we have 5 divided by 2 minus I. The conjugate of 2 minus I is 2 plus I. Multiply the numerator and the denominator by 2 plus I, distributing. We have 5 times 2 is 10. 5 times I is 5I. On the denominator, we have 2 times 2, which is 4. 2 times I is positive 2I. Minus I times 2 is minus 2I. And negative I times I is negative I squared. So on the numerator, we still have 10 plus 5I. On the denominator, note that 2I minus 2I cancels out. That's the whole point of multiplying by the conjugate, is so that the middle term cancels out. And then we have 4 minus I squared is negative 1. So we have 10 plus 5I all over 5, splitting the fraction and simplifying. So we have 10 over 5 plus 5I over 5 to give me 2 plus 1I, or simply I. The principal square root of a negative number. For a positive real number b, the principal square root of a negative number, negative b, is defined by the square root of negative b I times square root of b. So basically, whenever we have a negative inside the radical, it's the imaginary I, and then you work with the square root of the number part. So on example 5, we're just basically writing the result in standard form, which is the a plus bi format. So here we have square root of negative 81 is 9i. The square root of 81 is 9, and then because it's a negative and the radical is the I, minus square root of negative 144. Well, we know that square root of 144 is 12, and it gets an I because there's a negative inside the radical, and 9i minus 12i is negative 3i. Example 6, we have negative 12 plus, because there's a radical with a negative inside of it, we have the imaginary I. So that's the first part. I want to make sure everybody understands that that's where the I is coming from. Then we're going to clean up square root of 28 just like before. Square root of 28, one of the perfect squares that goes into square root of 28 is 4 times 7. So here's negative 12 plus I, breaking up 28 into 4 times 7, and this is all over 32. So we have negative 12 plus square root of 4 is 2, square root of 7, I don't know. So we have 2I square root of 7 all over 32. And we could rewrite this again and simplify it, putting both of them under 32. So we have negative 12 over 32 plus 2 over 32, and then we'll leave the I square root of 7 part alone. So cleaning this up, we're going to divide by 2, actually 4. So you could divide negative 12 and 32 by 4, so it gives me negative 3 over 8, plus on the other one we can divide by 2, so that gives me 1, or just 1I square root of 7 over 16. So I said 1I, or just simply I square root of 7 over 16. Sometimes you might have to write it in proper a plus bi format, so you might have to say negative 3/8 plus square root of 7 over 16, and then the I afterwards. Just see how my math lab wants it. Example 7, we have negative 15 minus, once again, we have a negative inside the radical. There's the I part, square root of 18 over 33. We have negative 15 minus I. A perfect square that goes into 18 is 9 times 2. We know square root of 9 is 3, so negative 15 minus 3I square root of 2 all over 33. I'm going to separate this and clean it up. So we have negative 15 over 33 minus 3 over 33 I square root of 2. Dividing by 3, we have negative 5 over 11 minus I square root of 2 over 11. And if my math lab wants it in the proper format, it might say negative 5 over 11 minus square root of 2 over 11I.